Looking at number 11 here, future value of an ordinary annuity. I'll be using this formula from the textbook. So we'll go ahead and transform that formula into Excel and plug these numbers in. So if you look at it, here's the formula written out in Excel, which looks a little different because you have to write it all on one line. So I put the parentheses in where they need to go. Well, then plug the numbers in. And the first thing the goal you're going to want to do is try to get n all by itself so you can solve for that variable. So the first step to do that is to multiply both sides by this 0.04. So it'll cancel out on the right side and you'll get to here. And now we need to divide both sides by 400. So we'll just be left with this bit. So you get to here. And so now we just have this, so we need to add 1 to both sides. And now we're finally at the point where we just have the term with the n, so we can finally solve for that variable. Now to get it down from the exponent, you have to take a logarithm of both sides. I'll use the natural logarithm. As long as you're using the same logarithm on both sides, you're doing the same thing to both sides, so the equation stays balanced. So the log of both sides, when you have an exponent inside a logarithm, you can bring it to the front and multiply. And logarithms are just numbers, so I've calculated here in Excel the log of 2.2 and here's the log of 1.04. And so really this equation, you could rewrite it with those values. It looks like this. So finally divide both sides by this number here and n will be all by itself. And I actually used the cell references so I could get an exact value in Excel. I took this value, A13, and divided by C13. And you get this. So the answer is actually 21 because we're looking for the value n, which is the number of payments the number of payment terms we need to make to get that future value of 12,000. And from our calculations, 20 won't be enough. It'll take more than 20. So then by default, we have to go up to the next whole number. After that 21st payment, we'll have at least the future value that we want of 12,000. For number 12, we're going to use the same formula we used for number 11 and just plug those values in. So let's pull up Excel again. So here's that same formula for the annuity that we used in number 11. And let's look how those numbers fit in. Future value is what we're looking for. It's what we don't have. The payment is $477 a month. We have 1 plus the interest rate. Now it says 3% compounded monthly. So you have to take that yearly interest rate of 3% and divide that by the 12 months to get the monthly interest rate. So it's 0.0025. So 1 plus 0.0025 goes there. And you also put that interest rate. It's what you divide by at the end. And then the number of payment periods is n. And we have 7 years and we're compounding monthly. So 7 times 12, you get 84. So we actually have all the values here on the right side. We can just enter those in Excel here or a calculator and figure out then what the future value is. I've actually taken this complex term here in the middle and calculated it separately off to the side. So that part in parentheses, it's the top part of the fraction. It reduces to this value. So this whole thing would reduce to these 3 numbers. And when you do that times that divided by that, you'll get the answer here. 44,524 would be the future value of that annuity.